You're listening to the Things Podcast, brought to you by the Things Industries.
Hi, I'm Alix Paultre, and I'm at the Things Conference today with Scott Smyser. He's with EMASS, a Nanoveu business. And what are you bringing to the show today?
Yeah, so we have Edge AI SoCs.
Oh, okay,
So-
very cool.
Yeah, so not the typical wireless technology you find here, but we're actually doing Edge AI SoCs, which are doing AI processing, AI inference on devices. So typically, AI, as you think about it, it's done in the cloud, right? When you talk about battery-powered devices, you want to be able to do AI processing on device, but very quickly, so low latency, and very low power consumption or energy consumption, so you're not burning up the battery, right? So that's what we bring to the table as a chip that can do that. Do this AI processing, AI inference directly on device without having to go to cloud as much.
Well, that is also a critical wireless technology, just not in the wireless sense of transmission receiving, but with all the connectivity in the world, unless the device actually has some smarts to do something, then it's just connectivity. There's no activity, no functionality. You have to have the functionality to go with it.
Right. Yeah. No, and that's what we bring to the table is, again, doing much more on device. One of the applications we're showcasing here, which marries very well with some of the wireless technology like LoRaWAN, is predictive maintenance. So we have our chip here on a eval board, and then we've got a pluggable sensor module. This one happens to be predictive maintenance. It's got an IMU on it. It's got a microphone and a barometer. So what this is meant to demo is that a module like this can be placed on a machine in a factory where you want it to monitor that machine continuously, right?
And it would support a digital twin.
Right. Look at vibrations, look at any sounds that are coming off of it. So our chip will do that alongside these sensors continuously. And when it detects an anomaly, based on the AI model we put onto the chip, then it'll wake the system up, say, hey, come check this out. Send a signal, come check this out because we detected this anomaly on the machine. So that's one of the use cases that we're out of here.
Well, and that whole predictive/preventative maintenance is a big field. Like, I mentioned the digital twin aspect, but you need that sensor data, you need that logic in the device to be able to project that data outwards so that, as you pointed out, it can say, hey, it's vibrating funny, those bearings are probably going to go in a month, send somebody out to fix them.
Right.
Or not.
Right. And the way it's done today is that, you're monitoring it on an occasional basis, right? Because you don't have an SoC like ours that can still launch sensors and do that continuously. You're sort of waking up, let's check it now. So you may be missing anomalies that really you wanted to catch.
Exactly. Well, because continuous real-time status knowledge, oversight of the system, you could check every 10 minutes and miss significant anomalies that would impact the health of the system.
Right. And that's what we do in other devices. So anything battery powered, right? Think of in a wearable. So a smartwatch, or I have a smart ring, or okay, you've got one too. We will sit there alongside the sensors in that system, right? You've got PVG sensing, the heart rates, you've got a temperature sensor, you even got the IMU that's detecting your motion, right? So our chip can sit alongside those sensors, enable real-time monitoring of those sensors, and then again, wake the system up, the central processor, application processor, send a signal saying, hey, I detected some rise in heart rates or something else you want me to look for. And I, tell this user now that there's something happening, right?
Well, Scott, we were talking a little bit about industrial. You mentioned some medical. Are there any application spaces that you're really seeing a lot of interest from right now?
Wearables is one that I was just talking about. Another one is drones. So what we're doing in drones is helping to extend flight time, payload capacity, and also more autonomous operation. So in drones, you've got a main system controller and a bunch of different sensing for the drone. We can sit alongside that system controller work alongside all that sensing and look, detect changes in, say, the winds, um, other conditions, and then give that feedback to the system controller and say, hey, make a slight adjustment in your thrust, make some adjustment in your pitch. And again, that'll help with the energy conservation of that drone. We can also then enable more autonomous operation, right? Swarm detection, collision avoidance. Again, these things right now are more so going to the cloud to get that data and coming back where, all right, if I want to avoid something, I have to do that pretty quickly, right? Or I want to do that pretty quickly. So that's what we can enable with our chip and drone. So we're getting a lot of interest in drones because we've actually done some simulation and testing to show how our chip can really benefit drones.
Excellent, Scott. So, when you think about all of these spaces and you think about all of these tools, what do you feel that the engineer should know about your company when it comes to the selection of the solution?
Yeah. As we talked about, latency and energy consumption, those are two keys. If you look at our solution versus the incumbents out there today that have Edge AI SoCs, we are the same or better latency and up to 20x lower in energy consumption, which is huge. I mean, when you talk about anything battery powered, right? To be able to extend that battery life or with that additional power budget to be able to do more on device, right? And the other thing too that we thought about ahead of time is how do you take the existing systems and drop in our chip? You've got existing software, existing models running, right? So we have this toolkit that allows your models or customers' models to be translated and optimized for our chip. So it's not something where you got to take our chip, the eval board, and then do some heavy lifting on the software programming side, right? You can easily take what you've done, translate it, and bring it up and running. So,
Excellent. So, was there anything about your technology or the company that we haven't brought up yet that you'd like our audience to know about?
yeah, so we are a 5-year-old company. Started in Singapore. There's some research out of university that was taken out, and that's how EMASS is founded. We now have our first commercial chip, engineering samples, eval boards. We're going to market. So if you want to try us out, we're ready.
Excellent, excellent. Do you have any last words for our audience before I let you go, Sky?
No, this has been great. I mean, I appreciate the time and the opportunity to talk more about EMASS. So
I'm really glad you had the time to come and talk to us. I'm glad you had a chance to sit down and chat about the company with us.
great. Thank you so much.
Thank you.